Hi everyone, this is Sharan here. Welcome to my channel. Today in this video, we are going to see in detail about decision tree. What is a decision tree? What are all the different types of decision tree in what type of scenarios that can be used? The key terminologies used in decision tree. I will be using the chart over here, a sample decision tree in order to explain the various terms that is used in a decision tree or to explain a tree-based algorithm. And how to build a decision tree. What are all the different algorithms? We are going to pick ID3 as an example, and then we are going to see how do we use entropy and information gain while building a decision tree algorithm. How do we actually build it? So we are going to see with a sample data. And what are all the various hyperparameters that are used while implementing a decision tree algorithm using Python. How to avoid overfitting while implementing a decision tree algorithm. And finally, we will also see about the disadvantages of decision tree algorithm. So you would exactly know what are all the various scenarios where decision tree cannot be used. Okay, now let's go into the detail. What is a decision tree algorithm? Decision tree algorithm falls into the category of supervised learning. So in case of supervised learning, we know the training data, like we know a data set where we know the input as well as the output. So we use this data set in order to train the algorithm, and hence we use the trained model in order to make the predictions. So that is the supervised learning. So we know the patterns already. So we know the input as well as the output. Second, decision tree algorithm is a non-parametric algorithm, which means that there is no strong assumptions being made. Most of the learning comes directly from the training data that is being present. So in order to explain you this better, let me explain what is parametric. So when I say parametric, one classic example is linear regression algorithm. Why it is parametric? Because there are some assumptions that is being made. For example, in case of linear regression, we assume that there is a linear relationship between an dependent variable as well as an independent variable. So that is the major assumption behind which the algorithm works. Whereas in case of non-parametric algorithms, there is no strong such assumptions being made. Most of the learning comes directly from the training data or the data that we have. So the more the data that we have, then the better the non-parametric algorithms would work. And finally, decision tree algorithm is very simple and easy to interpret because the algorithm is simply rule based. So we would be able to interpret the algorithm easily and understand what's happening, what are all the various patterns or insights, or what event is triggering a particular output. We would be able to get all those information directly from the algorithm because it is decision based algorithm and it is very easy to interpret or to study. Moving on to the types of decision tree algorithm. Decision tree algorithm can be used for both classification and regression problem. When I say classification, let's say we want to predict whether an transaction is a fraudulent transaction or not, whether an email is spam or not. All these kinds of classification problems, decision tree can be a good algorithm to solve it. It can also be used for regression problems. For example, we want to make a prediction of a property price. So we can still use decision tree algorithm for even regression algorithms. It is the algorithm that we are going to use might differ. There are few algorithms, for example, ID3 is not suitable for making a regression for a regression problem, whereas there are other decision tree algorithms that can be used for a regression problem as well. So when I say types of decision tree, it is both classification as well as regression. So there are decision tree algorithms that can be used for both the scenarios. Next, what are all the key terms that is commonly used while building a decision tree? So now let's move on to the board and then let's see what are all the various terms that is commonly used in a decision tree or while building a decision tree. So the first one is the first one that you see on the top. So that is the root node. And the one that you see on the bottom, the one with the red circles. So these are all the terminal or the leaf nodes. So these two are the important ones. The root node, the decision tree starts with the root node and ends with the terminal or leaf node. It has various decision nodes. For example, this is the decision node, windy, whether it is true or false. Whenever there is like a different options or the tree is getting split, it is called as a decision node. And then this is the split, where from this node there is a split. There are two different options. So this is a decision node as well. And then there is a split. So whenever there is a decision node, there would be a split. It can be 2, 3, or it can be anything, like it can be more than that as well, depending upon the number of possibilities. And the parent as well as the child node. So when I take this particular node here, so this is the parent node for this node, and these two are the child nodes. So these are all the parent and child nodes. And finally, pruning. So pruning is a concept where when we want to cut the tree. For example here, so this is the terminal or leaf node. Let's say I want to stop it here. So that is called as pruning. So when we want to stop the tree before it actually ends. So that's called as pruning. That is a technique that is commonly used to avoid overfitting, so which we will see in detail a bit later. So what are all the different algorithms? There are various algorithms that can be used in order to build a decision tree. Some of the common or popular algorithms are, some of them are mentioned here: ID3, CH8, CART, and C4.5. So these are all some of the algorithms that are commonly used while building a decision tree. The one that we are going to see today is ID3. So we are going to see in detail with a sample data how to build a decision tree using the ID3 algorithm. So it uses something called as an entropy as well as information gain. The formula for entropy and information gain are provided here. We will see about this particular method that is used in order to build a decision tree for a sample data. The other algorithms that you see here, for example CART as well as C4.5, it uses different techniques in order to build the decision tree. So it doesn't use entropy or information gain, it uses much more information. For example, C4.5 uses gain ratio in order to build a decision tree. CART method uses something called as an Gini index in order to build the decision tree. And in case of CH8, it uses the chi-squared metric in order to build the decision tree. So these different algorithms uses different concepts in order to build the decision tree. So what we are going to do is we are going to just see now in detail about the ID3 algorithm, where we use something called as entropy and information gain in order to build the decision tree. So let's get into the example and then see how it works. Let's see how to build a decision tree using the sample data. So as you see on my screen, so this is a sample data which we are going to use in order to see how to build a decision tree. So this sample data is a popular data set that is commonly used in order to explain the working of decision tree algorithm from a popular machine learning book. I will provide you the link to the book, and now let's get into the details. So this is a sample data where we have 4 attributes. We have outlook, we have temperature, we have windy, whether there is a weak or a strong wind, and we have humidity. So we use all these 4 attributes in order to predict whether we can play or not. So it can be anything. It can be golf, tennis, like you can consider whatever it is. So based on these 4 parameters that you see here, outlook, temperature, wind, as well as humidity, we are going to predict whether to play or not. So for this one, let's see how to build a decision tree using the ID3 algorithm. So going to the math behind the algorithm. So first one, let's state the target column, which is decision to play. So it has to be whether yes or no. So there are about 9 cases where it is yes, and there are 5 cases where it is no. So in total there are about 14 records. So what we are going to do is we are going to calculate the entropy for the target attribute, which is decision to play. So how do we calculate the entropy? So the entropy is calculated based on this particular formula here. So it is the summation of negative pi log of pi. So when you go into this particular example here that you see on my screen, so what I am going to do is the probability for S is 9 by 14. So there are about 14 records. In 9 cases it is S. So what I'm going to do is I'm going to do negative of, as you see on my screen, negative of 9 by 14 multiplied by log of 9 by 14 to the base 2, and negative of the second case. Second one is no. So which is out of 14 cases, there are 5 cases where it is no. So 5 by 14 into log of 5 by 14, and the log is of base 2. So this particular formula here that you see here gives us an result of 0.940. So this is the entropy for decision to play. So now what we are going to do is we are going to see what should be the root attribute. So what attribute? There are 4 attributes, right? So there are 4 attributes such as outlook, humidity, windy, and the 4th one is temperature. So out of these 4 attributes, we want to know what is the attribute that should be taken for the root, like what should the attribute that should come on the top. So for that, what we use here in case of ID3 is we use information drain. So we use information drain in order to identify the attribute with the maximum information drain and choose that attribute to the root attribute. So then what we do is, now we know the entropy for decision to play, which is the target attribute. So now what we are going to do is we are going to combine this with each of those 4 other attributes. So we are going to see what is the information drain when we have both decision to play, the target attribute, as well as outlook, or decision to play and temperature, with the other attributes such as humidity as well as windy. So we will see by combining which 2 of them the information drain is highest. So then that becomes the root node. So now here is an example where I have outlook and I have decision to play. So this is how, like if I just take those 2 attributes, so this is how the distribution would look like. So there are 3 possibilities for outlook. It is a sunny, overcast and rainy, and in case of decision to play, it is yes or no. And then this is the split between each one of them. So after generating this particular table here, so first what we do is we calculate the entropy for the combination decision to play and outlook. So how do we do it? So this is the formula here. So for in case of sunny, there are out of 14 instances, there are 5 instances where it is sunny. So what we do is, so here in this case we take 5 by 14 entropy of E, 3 and 2. So these 2 cases, and plus what we do is 4 by 14. So here for overcast, there are 4 instances where it is overcast. So 4 by 14 multiplied by entropy of 4, 0, because it has 4 cases where the decision to play is yes, and then 0 cases where the decision to play is no. And similarly, plus 5 by 14 multiplied by entropy of 2, 3. So in case of entropy, we know what the formula is. So here when here in this case when we have E of 9, 5, so what we did was, it was 9 by 14 multiplied by log of 9 by 14 and minus we had 5 by 14 into log of 5 by 14. So here in this case what we have is we have 3, 2. So what would happen is the formula would become 5 by 14 into minus 0.6, because 3 divided by 5 is 0.6. So minus 0.6 into log of 0.6 to the base 2 and minus 0.4 into log of 0.4, because 2 divided by 5 is 0.4. And similarly the second one, so here we have entropy of 4, 0. So here in this case this becomes 0, because we have one particular, like because whenever it is overcast, it means that it is 100% the decision to play is always yes. So the tree ends right over there. So as you see on the board here, so when it is overcast, it is always yes. So the tree ends right away. So the entropy is 0. So in that case, what happens is the middle part, which is this one that you see here, E of 4, 0, this particular portion becomes 0. So plus we have the final portion, which is 5 by 14 E of 2, 3. So E of 2, 3 will be same as E of 3, 2. It's just the sequence would change. So if we solve this particular equation, so as you see here, if you substitute the value here on the top, the value would come to be 0.6935 and so on. So now how to calculate the information drain? So in order to calculate the information drain for the 2 attributes, which is the target as well as outlook, what we do is we do entropy of the target minus entropy of the target as well as the attribute that we are choosing. So here the entropy for the target is 0.94, and here the entropy for decision to play as well as outlook is 0.6935. So when we subtract 0.6935 from 0.94, the value is 0.2467. So this step that we see here needs to be repeated for all the combination. For example, now we have done it for decision to play and overcast. So this needs to be done for decision to play and temperature. decision to play, and humidity, decision to play, and windy. So when we do all of these, whichever combination has the highest information drain, so that attribute would become the root attribute as per the ID3 algorithm. It uses entropy as well as information drain concept in order to choose the attribute that should form the root attribute, and so on. We use the same method. Entropy as well as information drain in order to choose the next attribute. For example, here in this case, Outlook has three options. It has sunny, overcast, and rainy. So after coming to this particular attribute here, again we see what would be the best option. So should we use windy attribute or humidity? So which works best? And we use the same concept in order to choose the next decision node, and so on until the terminal nodes are reached. So this is the concept in order to build an decision tree algorithm. The other algorithms, for example, in case of a C4.5, we use a drain ratio in order to build the decision tree, which is slightly different. So in case of CART method, we use something called as a Gini index in order to build the decision tree. In case of CH8, we use chi-squared metric, a statistics metric, in order to build the decision tree. So depending upon the algorithm that we choose, the method that is used in order to build the tree would be different. So depending upon the algorithm, the type of tree or the structure of the tree might change because the methodology that is involved behind them is different. Okay, now what are all the various hyperparameters that we would commonly use while building a decision tree? Some of the commonly used hyperparameter would be the criterion. So what should be the methodology that should be used in order to build the decision tree? Should we use entropy and information drain, or should we use drain ratio? So it defines what type of algorithm or technique that we need to use in order to build the algorithm. What should be the maximum depth of the tree? So should it go as long as it can go? If it goes too deep, then it can become an overfit. So we usually define how big or what should be the depth of the decision tree. What should be the minimum samples in order to do a decision or in order to do a split? So when we reach at each of these points, how many samples should it have for us to divide it into further nodes? So that would be one of the hyperparameter that we would choose. What is the maximum number of leaf or terminal nodes that are allowed? So here in this case, we can see that there are 5 terminal nodes. We can pass on and hyperparameters which defines the number of terminal nodes for a particular tree that we are trying to build. So these are the 4 hyperparameters that are commonly used while building a decision tree algorithm. And the next one, the most important one, is what is an overfit and how can we avoid overfit while building a decision tree. Overfit can commonly occur while building a decision tree because if we let the decision tree to grow as much as it can, so the deeper it goes, it becomes an overfit. So when we have a new data set, so maybe then the prediction might go wrong. So in those cases, in order to stop or in order to avoid the overfit, what we use is we use commonly 2 techniques. One is pruning. So pruning, as I defined, we stop the tree from growing too deep. So we mention how long or how much depth the tree should grow, and the algorithm would stop the tree from growing any further. And hence what happens is it avoids the overfit. The second one is a random forest. So random forest is an ensemble model where what we do is we take different samples of data. Instead of using all the training data in order to build the decision tree, so what happens is we take a portion of the sample data. Let's say we use like maybe 20% of the data, build a decision tree, take another 20% of the data, again build a decision tree, and we kind of try to build multiple decision trees and combine all of them together. So that's why it's called as an ensemble model, or it's called as a random forest, because it has many trees in it. And also, not only we create subsets of the training dataset, we also use subsets of the features. For example, here in this case, we had 4 features, 4 attributes, such as overcast, rainy, humidity, and temperature. So we use maybe 3 at a time, build a decision tree, and then and then we take another 3, and then again build a decision tree, and then combine all of them, and then see how the results are. So by these methods, what happens is we can avoid an overfitting. And finally, what are all the various scenarios where, or like why decision tree cannot be used? Some of the common disadvantages of decision tree are whenever there is small changes to the training dataset, the tree structure can totally change, because this is a non-parametric algorithm and the algorithm is highly dependent on the dataset that we provide. So if there is any changes to the training data, the tree structure might totally change, and hence the prediction and the output might change. And the second disadvantage is the larger the training data set is, the slower the algorithm would be. So it takes a lot of time in order to build the trees. So if we are going to use random forest, it is going to build the tree multiple times for the same data set. Like it is going to take different samples, build different number of trees, and then finally it would take an average of all those. So it is a very time consuming process. So if you have a very large data set, so maybe going for a decision tree might not be very suitable if you have any limitations on maybe your system RAM or so on, because it is going to take a lot of memory as well as a lot of time in order to build the prediction. So that is it about the decision tree algorithm. So that is the concept about decision tree. So these are all the various formula that is used in the ID3 algorithm. There are other few algorithms as well. What I will be doing is I will be providing you a link in the description where you can find some material in order to learn more about decision tree. In the next video, we are going to see the implementation of a decision tree. So the sample data that we saw, in order to explain the working of the ID3 algorithm, we are going to use the same data, and then we are going to see how to implement decision tree using Python. So let's see about the implementation of decision tree in the next video. And bye until then. If you like what I am doing here, if you are learning something new here, please hit the like button as well as subscribe to my channel. And if you find this useful, please share it with your friends as well. And finally, if you think there are any interesting resources in order to learn more about decision tree, please share them in the comment section. Yeah, that's it for now. Bye until we see in the next session.